Okay students, welcome to the next lecture of Biomedical Engineering. Today we will start Unit 6. Today we will see Unit 6. The Unit 6 title is Monitors, Recorders, Shock Hazards. So this unit title is Monitors, Recorders, Shock Hazards. Let us see the contents of this unit. Coming to here, the topics. Biopotential amplifiers. The first concept in today's lecture we will see what is meant by biopotential amplifiers. Next we will see monitors, recorders and shock hazards and prevention. Next physiological effects and electrical current, shock hazards from electrical equipment, methods of accident prevention, isolated power distributed system. These are the course contents now I have read. Now see the first one. Biopotential amplifiers. In this concept, we know that different types of electric potentials, bioelectric potentials are available from our human body. That is, we have seen in the previous classes. Okay, how the different types of bioelectric potentials are managed and diagnosed by using different types of equipments from the cardiovascular system, from the respiratory system, from the from our human body, different internal organs. So from these internal organs, how to collect the bioelectric potentials we have seen in the previous class. So for increasing the amplitude of this type of bioelectric potentials, we are using biopotential amplifier. A biopotential amplifier which will boost up the signal energy, or it boosts up the less consumed energy. Otherwise, we can say that the bioelectric potential, we can call this one as less amplitude signal, right? So we can call bioelectric potential as a less amplitude signal. So what is the meaning of this one? We have seen a lot of concepts in the previous classes. The potential which is collecting from the human body is with very less amplitude. So our machines cannot process that type of bioelectric signals. For processing that type of bioelectric potential signals, we need a biopotential amplifier. So we will see different types of biopotential amplifiers used in the biomedical field. Next, monitors. So monitors, we can see different types of monitors in our home also. So for computer system, it has a separate display that is called monitor. In generally, it has different types of screen resolutions. And at the same time, in each and every home, we have television system. In the television system, also we have some resolutions which will be lesser than the computer monitor. Why? Because the computer monitors are basically designed with a high resolution parameters. Coming to that, our television systems are designed with, compared to PC systems, PC monitors, these are the less resolution systems. Okay, for the same cost. If the cost is increased for the television systems, automatically high resolution TVs presently in the market commercially they are available. Right. So we will see different types of monitors which are using from the starting of the biomedical field, that single electron display, that is, we have different types of tracing signals which will be used in the space centers, Indian Space Research Organization centers, ISRO centers. We are using some displays which is called tracers. Okay, tracers are signal followers, are different types of CRT displays. So these are the displays we will see in this concept. Next, recorders, where the recorders are nothing but as olden days printers. In the present day printers, we have inkjet printers and laser printers. In the previous days, we have pen type printers. We have a pen type arrangement in the printers. That printer is drawing the signal. The printer is going to draw the signal which will identify the bioelectric potential from the human body. Based on that bioelectric potential, it will draw a graph. That type of graphs we can see by using this type of olden days printers called recorders. That is, this is also one type of printer, but olden days this is called recorder. We have different types of recorder: galvanometric recorder, X-ray recorders, we have strip chart recorders, ultraviolet recorders. Like that, we have a lot of recorders that we will see. And next, coming to this 4, 5, 6, 7, 8 concepts are related to the safety of the biomedical equipment with the patient. Okay, so when the biomedical equipment is connected to the patient, it should provide safety. It should not generate any electrical shocks to the patient. Why? Because most of our home purpose electronic gadgets, or maybe TVs or computer freeze, sometimes they will if any short circuit is happened, so sometimes they will provide shock. Okay, so that is called an electrical accident. The shock we can call also electrical accident. Okay, so these type of electrical accidents generally occur with the electronic equipment or electrical equipment. Okay, so how to provide a good safety for the patient from this biomedical equipment? We have to provide double safety, right? All the electronic equipments or electrical equipments are coming with some safety precautions. But coming to in this case, the patient safety is the major important parameter for our biomedical engineers. For them, for providing a good safety for the patients, we have to provide double safety. How the double safety is we are providing with this concept. So for that, first we will see what are the different types of shocks are available and how to provide, how to prevent the type of shocks. Next, we will see what happened when the electrical shock is connected to the patient. Then what is the internal effect, physiological effect, what happening to the physiological systems of the human body. Next, different types of electrical equipment which will eliminate this type of shocks that we will see here, and methods of accident prevention and isolated power distributor system. So these are the topics we will see in this unit. Okay, let us enter into the today's topic, that is biopotential amplifier. Right, biopotential amplifier. For understanding this concept, first you have to imagine yourself what the concepts we have discussed in the previous classes. That is, the first one, biopotential. The biopotential. So see here the definition of this one. Amplifiers are used to process biopotentials are called biopotential amplifier. So see carefully, first I will explain this one. Amplifiers. We have a lot of amplifiers. We have studied these amplifiers in the second year subject. Class A power amplifier, voltage amplifier, current amplifiers. Alright, there are different types of amplifiers we have seen. So like that, the amplifiers which are used to process biopotentials, right? So from our human body, we are taking some potentials. These potentials we are doing, we are processing, right? So the amplifiers which are used to process biopotentials is called biopotential amplifier. It is called biopotential amplifier. That's a very simple definition. Next, biopotential signals. We have different types of biopotential signals. So see here, we have different types of biopotential signals. The first one, electrocardiography. Electrocardiography, ECG. So we know very well about ECG. The ECG is generally used for measuring the electrical activity of the heart. Okay, so our heart will generate some electrical energy. What is the purpose of generating electrical energy? To pump the blood towards all the organs of the body. Okay, the heart functionality is pumping the blood to the internal organs of the body. That is a major working condition. So for pumping the blood, it needs some energy, that is electrical energy. That electrical energy is nothing but as in general we are calling as conduction system of the heart, right? That conduction system we are measuring with a machine that is called electrocardiography. This electrocardiography, it will provide the electrical activities of the heart. Second one, EMG, electromyography. So in the muscles also we have some potentials. So for example, if you are holding this arm like this, that means the arm is working right? For that arm, we have to send some bioelectric potentials. Okay, so that is the bioelectric potentials. These bioelectric potentials are measured by using EMG, Electro Myo Graphy. So in our total human body, we have a lot of bioelectric potentials. These biopotentials we are calling different places. These potentials are calculated by using different machines: ECG, EMG, Eeg, electroencephalography. These type of electrical activities occur in our brain. Right? From our brain, we are measuring different types of electrical activities. This type of machine is called electroencephalography. Electroencephalography. Next, EOG. Electrooculography. Electrooculography is completely deals the electrical activities which will be involved in the oculogram, that is related to retina. Okay, EOG, ERG, electroretinogram is also available. So these are the different types of electrical potentials, bioelectric potentials. And not only these four, we have still lot of bioelectric signals are available from our human body. Right. Next, coming to that. Right. So these are the different types of bioelectric potentials now we have seen. Next, the basic function of the biopotential amplifier to increase the amplitude of weak electrical signals of biological origin. So from our biological system, we will get a lot of bioelectric potentials. Okay, all these bioelectric potentials, most of the human body bioelectric potentials are with very less amplitude signals. So for that weak electrical signals, we have to amplify. We have to amplify those type of signals. So the basic function of biopotential amplifier to increase, right? To increase or to enhance the amplitude of the weak electrical signals, weak bioelectrical signals, right? The weakest bioelectrical signals, we are increasing the amplitude. That is the main purpose of the biopotential amplifier. What exactly the biopotential amplifier will do? Tell me again. The biopotential amplifier increases the amplitude of the weak electrical signals from our human body. Is it clear? So this is the definition of bioelectric main purpose of the biopotential amplifier. Biopotential amplifier. Next, biopotential amplifiers typically process voltages, but in some cases they also process currents. Basically, biopotential amplifiers are two types. The first one, voltage amplifiers. The second one, current amplifiers. There are two types of biopotential amplifiers. So these are generally deals with voltages or currents. The frequency response of typical bioelectric amplifiers may be from DC or near to DC, that is 0.05 Hz up to 100 kHz. Basically, from our human body, lot of bioelectric potentials are there. Those bioelectric potentials, they have frequency range from 0.05 Hz to 100 kHz. Most of the bioelectric potentials have frequency is less than 100 Hz only, but in some cases it may be 1 kHz or 2 kHz also. So that is a maximum frequency is 100 kHz. So from our human body, we have different types of electrical potentials with the frequency of 0.05 Hz to 100 kHz. 100 kHz. Next. So see, one example of bioelectric potentials amplifier, one example of biopotential amplifier. So bioelectric potential amplifier with some differential amplifier. So see here, this triangular symbol we have seen in the third year first semester in linear integrated circuit applications, LICA subject. So this is an op-amp. Op-amp has generally two terminals, that is inverting terminal, and non-inverting terminal. Where this minus indicates, now inverting terminal and this plus indicates non-inverting terminal. That means if you are giving any two signals in between these two terminals, it will give the difference of that value or sum of the value. So basically, we are using a differential amplifier. Basically, we are using a differential amplifier. Okay, a basic differential amplifier with a ground is also here there. These two lines are nothing but as the whatever the biopotentials we have taken from our human body, those bioelectric potentials we are giving to this op-amp at inverting and non-inverting input terminals. So see here, these wires are connected to the electrodes. These electrodes are connected to the patient. That means the internal organs generated bioelectric potentials are completely connected to the op-amp, are completely connected to this op-amp. Okay, after this op-amp, we have high frequency filter. Okay, that means see here, the human body allows different types of bioelectric potentials, and these are all the bioelectric potentials maximum frequency range is 100 kilohertz. So more than 100 kilohertz, if any signal is generated, that is not related to our human body. So we have kept a high frequency filter. So whatever the high frequencies are coming, so this filter, all the high frequencies are removed from this signal, which will be collected from the differential amplifier output. So after that, the remaining signal we are taking printout. Olden days printer is called recorder and monitors. So in the display we can see different types of signals which will be collected from the human body by using this mechanism. So in this mechanism we have an op-amp, high frequency filter, recorder, monitor. So the bioelectric potentials we are giving through the electrodes to the input of this op-amp. And this op-amp is the functionality consisting of some differential amplifier. So some output it will give. So from that output we are eliminating the high frequency signals, and the remaining original signals we can see by using a on a paper, by using a recorder. Otherwise we can see on a screen, that is a CRO, cathode ray oscilloscope, or LED or LCD screens. But in this unit we will discuss about the CRT screens only, and because of in the olden days we have only CRT screens. So in the monitor we can see those bioelectric potentials. So this is a basic structure of a differential amplifier. Next, coming to that before going to that biopotential amplifier, we have seen the introduction, how the biopotential amplifier will be available and what is the output. So remember one thing, whatever the potentials we are collected from the human body, those signals we have to see on a display. Otherwise we have to take a printout, right? Only we have two targets. The first one we have to take printout. Second one we have to see on the display. Okay, right? But see, we have different types of sizes of displays. 15 inches display, 19 inches display, 20 inches display. Different types of displays we have availability. So for displaying the signal, we need a strongest biopotential amplifier. So we need a strongest biopotential amplifier, right? So when you are going to design any instrument for recording the biopotentials from the human body, you need to find this which type of biopotential are you required. Which type of biopotential amplifier is required, that is choosing of biopotential amplifier is very important. Okay. Apart from the normal requirement of the instrumentation amplifiers, the biopotential amplifiers have some some requirements. Those requirements now we will see one by one. The first one, input impedance should be high in order to 10 mega ohms, so that negligible loading is provided with the biological system being measured. So we have to avoid the input loading. So for that reason, we need to take a biopotential amplifier with high input impedance, that is nearly 10 mega ohms. So that is the first important parameter. Second one, amplifier should have high gain in the order of 1000 or more, so that the weak biological signals of the order of millivolts or microvolts are amplified. So this is millivolts and this is microvolts. Okay. So generally in our electronic laboratories we are dealing most of the times with voltage levels. So 1 volt, 2 volt, 5 volt, 10 volt, 20 volts signals we have operated. But from our human body we have very less amount of voltage. It may be millivolts, microvolts. So for operating this type of bioelectric potentials, we need a good amplifier with a good gain. So generally we have seen gains with 100 or less than 100 only in our electronic circuits. But in the biomedical field, the biomedical equipment should consist of nearly gain is 1000. 1000 gain. Which type of biopotential amplifiers has 1000 of gain? That type of biopotential amplifiers are helpful to design biomedical equipments. Next, this is a very important parameter. These amplifiers should have high CMRR. So, common mode rejection ratio, CMRR. Common mode rejection ratio is very important parameter for an amplifier. These type of biopotential amplifiers should have high CMRR. This is very important one. Next, voltage appearing at the amplifier due to the input changes in magnetic field should be minimized. So, when you are taking some bioelectric potential from the human body, so in the surroundings place, it may be in the circuit surrounding places, we have to remove some magnetic fields. We have to remove, if it is there any magnetic field, we have to remove that fields in any places. Okay, so that is very important to get a perfect measurements. That is very important one. Next, amplifiers should have isolation circuitry for the safety of the patient being studied. So, isolation. Here, in this point, we said that amplifiers should have isolation circuitry for the safety of the patient. So, for the safety of the patient, we are providing double safety. That double safety we are calling as isolation circuitry. So, isolation. What is meant by isolation? Isolation means we have only one side entry. Other side entry, it is not available. It is like as a one-way road. Right? We can enter into the road, but we cannot come back on that same road. Okay, so like that it allows signal in only one directions. From the patient to we can take biological signals. From the equipment to for the patient we can give the minimum voltage to identify different measurements from the patient. Right? More than that, the other signals are not allowed, which will be harmful to the patient. Whatever the harmful electrical currents will be available, those will not be entered onto the patient's body with this isolation circuit. The isolation circuitry is very important. Right. Next, see, so this is a basic instrumentation amplifier. This is a basic instrumentation amplifier. In this instrumentation amplifiers, here we have first op amp. Here we have second op amp. This op amp names are A1, A2, and here we have one more A3. Totally we have three op amps. First one A1, A2, and A3. Right. Next, for the first op amp, we are giving some signal E1 plus ECM. Here also we are giving some input signal E2 with ECM. And so these two biopotential amplifiers outputs are connected to the this third op amp with one inverting terminal and one more is a non-inverting terminal. So for non-inverting terminal, the A1 is connected and inverting terminal of the third op amp is connected to the second op amp output through a resistance R6 and R3. Okay, so the A1 op amp output is connected to the A3 op amp through R3. The A2 output is connected to the A3 inverting terminal input of the op amp with through R6. And these two outputs are connected with R2 and R3 R1 resistance, variable resistance. This resistance is available for adjusting the voltage gain of this total amplifier. So this total amplifier called instrumentation amplifier. Instrumentation amplifier, and this is the feedback path from the last op amp output to it's the same input. So these are the basic arrangements. Let us see clearly. In normal practice, the operational amplifiers are used as an instrumentation amplifier. Normal operational amplifier we are using as an instrumentation amplifier. The first stage comprises two input amplifiers A1 and A2 connected in the non-inverting followers configuration. This gives high input impedance. The second stage is the basic differential amplifier giving high gain. In this circuit, overall voltage gain can be controlled by adjustment of R1. So I said that in the total circuit, the R1 is the voltage gain adjustment. So see here, the first A1 op amp we are connected to the non-inverting terminal. The same non-inverting terminal op-amp output is connected to the non-inverting terminal of the A3 for getting the high gain, right? For getting the high gain. So in between the last op-amp and input signal, I have used A1 op-amp. In the same way for A2 also, here in between the last op-amp and input signal, I have connected one more terminal here with the for getting the high gain, right? So this is a basic instrumentation amplifier. So coming to here, in this circuit generally, R4 is equal to R5 is equal to R6 is equal to R7. R4. So this is the R5, R6 and R7. These are the R4, R5, R6, R7. If these are the equal resistances, then EM plus E1 is the input amplifier A1, and here these two are equal. And second one, here the inputs. Now we are taking the inputs. There are two types of inputs at A1 and A2. At A1, EM plus E1, and A2, EM, ECM plus E2. These are the two input signals of the two op-amps. Next, if R2 is equal to R3, then the final signal ES, where the ES signal is the output of here. ES signal is the output of here. Otherwise, you can call it as E5. ES is equal to 1 plus 2R2 by X of E2 minus E1. So this is the final output equation, right? The input amplifiers A1 and A2 acting as a input buffers. So this A1 acting as a buffer and A2 acting as a buffer, and A3 is the final op-amp with the unity gain for common mode signal ECM, and with gain of 1 plus 2R2 by R1 for the differential gain. For improving the gain, this is the basic connectivity. This type of amplifiers work biomedical amplifier due to very high input impedance and high gain and high common mode rejection ratio. This type of amplifiers has very high good CMRR and high gain. So this is about the basic amplifier. Next, coming to that, this is a basic analog multimeter. In the multimeter, we have different types of values. Whenever this multimeter is connected to some source, how much voltage is available, that voltage here it will show. Okay, in the biomedical field, we have this type of analog recorder in the previous days. So in this analog meter, 0 to 100 meter, the pointer is rotating, right? Where this pointer is connected? This pointer is connected to some galvanometric recording based system. So this is a permanent magnet. In this permanent magnet, we have a armature frame. This armature frame is connected with this pointer. So whenever the magnetic field is raised in this magnet, then this pointer is moved from left to right, Okay. So this pointer, how it will move? Who will give the directions to move this particular pointer? That is next topic. So see here. So this is a circuitry, and see here I have written here some pen coil. This is pen coil. This is the pen coil. This is nothing but as this armature section connected a pointer or needle. So this is connected here. So the remaining circuitry I have placed here. In this remaining circuitry, 4 transistors are available: T1, T2, T3, T4. Okay, right. So 4 transistors are connected. Let us see the operation, how the deflections will come in this instrumentation, in this galvanometric based output recorder. Output stage using bridge amplifier for driving galvanometric recorder. I said that this is the galvanometric recorder. In this galvanometric recorder, output stage is constructed by using bridge amplifier. Here we have 4 transistors. These 4 transistors we have connected like a bridge fashion. Right. Normally, the transistorized circuit is provided at the output stage to supply current to the pen coil of the galvanometer. Here, the outputs we are connected through using this bridge circuit. The pen motor is driven by a DC driven stage feeding a 4 transistor output stage operating at the galvanometer. Right. So this pen galvanometer, 4 transistor is connected in this circuit. So this galvanometer is controlled by using either T2 or T4 or T1 or T3. But here the combination is T1 and T2 combinedly controls the voltages in the pen coil, and T3, T4 is combinedly controlling the voltages in this pen amplifier. This is very important one. Okay, so coming to here, due to low power efficiency of push-pull amplifier, a bridge arrangement is preferred. Previously, for the galvanometric recorder based system, class B push-pull amplifier is used, but we have removed that one and we have provided a bridge amplifier here. So the current in T1 and T4 decreases and T2, T3 is decreases. So see here, whenever the current is increased at the T1 and T4 transistors, automatically T2 transistor and T3 transistor current will be reduced. At that time, the current is reduced at these two transistors. Now, the bridge is connected from main power supply to T1 and pen coil and T4. Next, it is connected to the ground. Okay, the voltage is traveled from this main supply to T1, T4 transistor to ground. Otherwise, T3 and pen coil T2, like if the voltage is passing in this direction only, then only the deflections we can control. If the voltage is passing in this direction, T1, T2 combinedly is controlled, then it is not operating any voltages. There is no deflections in that particular pen drive or pen controlled recorder. Okay, that is very important. So, thus when T1 and T4 approximates to short circuits, T2, T3 are nearly cut off. So whenever the voltages are passing, so it is seems to be like a short circuit in this way. So this is a short circuit. This is a short circuit. Okay, this is a short circuit. And this is seems to be like as in a open circuit. This is seems to be like as in a open circuit at these two transistors. At these two transistors. Okay, right. T1 and T3 function as emitter loads and T2, T3 operates at the amplification having T1 and T3 collector loads. So generally here we need to connect as a load circuit in this instrumentation amplifier for the galvanometric pins. So for that here we are connected the total circuit in this fashion. Okay, so this is about galvanometric recorder based system. And coming to this type of biopotential amplifiers, majorly we are using in the field of different places. So the first one, body surface potentials, which are ECG, EG, EMG, ERG, EOG, these type of potentials. So where we are measuring this type of electronic equipment or biomedical equipment. For this type of biomedical equipment, this type of biopotentials are used in the previous days. And multi-channel applications, Eeg Brain Mapping. So when you are collecting the brain electrical activities, you will use 40 electrodes on your brain. On your brain, you are placing 40 electrodes or 20 electrodes. From that, multi-channel recording facility is very, very important. At that time, we are using these principles, galvanometric recording principles or instrumentation principles. Next, evoked potentials we need to use, and microwave potentials and extracellular recording, microelectrode recording, and this type of all the applications are very, very important for using the biomedical amplifiers in the olden days. But in the present days, we have a lot of applications. These are the applications as per the syllabus and the test work. But these applications are very widespread in the present day technology. Okay, let us see some of the advanced systems in the coming classes. In the next class, we will see the concept of recorders. Okay.